Good day everyone, this is Bernadette M. Magaling again, and now I'll be discussing decision theory. So here we have 4 learning objectives, which are first, to state the fundamentals of decision theory, its environment, the difference between decision making under uncertainty and under risk, and the criteria of decision making under uncertainty. So first, let us define what is decision theory. So decision theory is a wide approach, or represents a general approach to decision making which is suitable for a wide range of management decisions, which includes the capacity planning design, location planning, product mix, product and service design, equipment selection, and credit policies. So decision problems is characterized by decision alternatives, state of nature, and resulting payoff. So we will define this in the next slide, wherein decision alternatives are the different possible strategies the decision maker can employ. So as the definition suggests, so decision alternatives are the choices the decision maker may make in order to solve the problem, while the states of nature refers to future events not under control of the decision maker, which will ultimately affect decision results. So these are the things that uncontrollable by the decision maker. So next is the payoff, wherein this is the consequence resulting from a specific combination of decision alternatives and the state of nature, wherein this is also what you call the result. And this can be expressed in terms of profit, cost, time, distance, or any other appropriate measure. So, kapag nakakita tayo ng payoff table, this is the combination of decision, alternatives, and state of nature. So, as I mentioned earlier, decision alternatives are the courses of action or strategies. States of nature is the uncontrollable, and the payoff is the result or the quantitative measure of the outcome. So to better explain the concept of decision problems, we have here the 3-egg omelette problem, wherein in the process of cracking and breaking the last egg of your omelette, napaisip ka bigla, paano kung bulok yung pangatlong itlog? E di masira yung ibang itlog. So may decision making ang gagawin kung ituloy mo pa bang buksan yung ikatlong itlog. So to better analyze the problem, here is a payoff table which as defined earlier, yung kung saan yung payoff table naman din ay nagasama-sama ng state of nature, payoff, at yung strategies or the decision alternatives. So here is the payoff table, wherein we have the state of nature, which is the uncontrollable, which are the third egg is good. So walang problema, maayos daw yung egg. So the third egg is rotten, so bulok daw. Anong mangyayari? So we have here the decision alternatives and choices na pwede nating gawin. Pwede nating break the third egg into the pan. So directly nating i-break. So break third egg into saucer and expect. So magkuha muna tayo isang tasa, tapos i-check muna natin, isihiwalay muna natin siya para makasigurado kung bulok siya or hindi. And the third alternative is to throw away the third egg. So hindi pa natin nabubuksan, itapon na lang para walang problema. So ganun. So yung payoff natin daw is, kapag binuksan natin yung third egg into the pan directly, so if the third egg is good, so we have the 3-egg omelette. So, pero kapag yung rotten daw, wala tayong omelette. So, meron tayong 2 egg na destroy. So, the next alternative is break the third egg into saucer and inspect. So, if the third egg is good, so we have 3-egg omelette and 1 saucer to wash. So, meron tayong isang tasa na huhugasan dahil sineparate mo natin siya. At kung ano man ang mangyari, at kung bulok man yung hiniwalay natin, so meron tayong 2-egg omelette, 1 saucer to wash kasi ginamit natin yun. So, the third alternative will be to throw away the third egg. So, itapon na lang para walang gulo. So, kung maayos man o hindi yung so meron tayong 2-egg omelette. May 1, kung siya ay good, syempre, nagsayang tayo ng isang itlog. Moving forward, we have here the decision environments, and under this are the certainty, risk, and uncertainty. So certainty is defined as is an environment in which relevant parameters have known values. So the best example of this is an investment in bank wherein this is certain as to future payments on maturity. And risk, on the other hand, is the environment in which certain future events have probable outcomes. This is only probable outcomes, so probability lang. The future is not sure, and the best example of this will be the investment in shares wherein the investment might fluctuate over time. So next is the uncertainty, wherein it is an environment in which it is impossible to assess the likelihood of various future events. So impossible daw. So the best example of this will be investment in shares with two fetching results in 2 years, which is impossible. So next is the difference between the risk and uncertainty. So risk, as defined earlier, is not known with certainty and can list all possible outcomes and assign probabilities to the outcome. So since this is not certain, so there can be a possible outcomes. However, when it comes to uncertainty, you cannot list all possible outcomes because it is uncertain and it is not known, and you cannot assign probabilities to the outcomes. So next in our topic are the criteria of decision making under uncertainty, which includes the following: optimism, pessimism, equal probabilities, coefficient of optimism, and regret. So under the optimism or the maximax or mini-min criterion, we will choose the alternative with the best possible payoff and locate the maximum or minimum payoff values corresponding to each alternative. So here we have the strategies 1, 2, 3 with the state of nature 1, 2, 3 and the row maximum, which in case of the strategy 1, the maximum is 7,000 into 5,000 and 3,000, in which we will choose the maximum, which is the strategy 1. So when we use optimism, we will choose strategy 1. Under pessimism, on the other hand, we will choose the alternative with the best of the worst possible payoff, as compared to optimism, which we choose the best possible payoff. We will now choose the best of the worst possible payoff. Locate the minimum payoff values corresponding to each alternative. So here we will choose again the maximum in this row, but we will with the decision we will choose the minimum. So here the maximum still is the 7,000, the maximum is 5,000 and 3,000, and we choose 3,000 because this is maximin, wherein minimum payoff values is important. So under pessimism, we will choose the strategies number 3. Under the Laplace criterion or the equal probabilities, on the other hand, all states of nature are equally likely. So we will compute the average and pick the highest row. Here we add the state of nature 1, 2, 3 and divide it by 3, and we get 3,833.33. Strategy number 2, 5,000 plus 4,500 divided by 3 is 3,166.67, and strategy 3 plus 3 plus 3,000 divided by 3 is 3,000, which the highest is the strategy 1, which we will choose. Next is the coefficient of optimism or Hurwitz, which represents a compromise between the optimistic and the pessimistic approach decision under uncertainty. So for each alternative, we select the largest and lowest payoff values, and we multiply this with a constant and 1 minus constant values respectively. Then we calculate the weighted average using the formula constant times maximum in column plus 1 minus constant times minimum in the column. So here, we will compute the H, which represent the H coefficient of optimism, and first we will determine which is the maximum in column and minimum in column. So in strategies 1, the maximum will be the 7,000 and the minimum is the 1,500. So we get the 4,800 by adding 0.6 times 7,000, which is the maximum, which is equal to 4,200, plus 1 minus the constant, which is 0.4 times the minimum, which is 1,500, and we get the 600, and if we add 4,200 plus 600 is equal to 4,800. In strategy 2, the maximum is the 5,000 and the minimum is the 0. So we get this by adding the product of the 0.6 times 5,000, the maximum, which is equal to 3,000, plus 0.4 times 0, the minimum, which is equal to 0, and 3,000 plus 0 is equal to 3,000. Next is the strategy 3, wherein we add 0.6 times 3,000, which is equal to 1,800, and 0.4 times 3,000, the minimum also, which is equal to 1,200, and 1,800 plus 1,200 is 3,000. So accordingly, we will choose the highest H, and this is strategy number 1 with 4,800. So last is the regret or salvage rule, wherein it represents a pessimistic approach. The opportunity loss reflects the difference between each payoff and the best possible payoff in a column. So here the column and not the row is the focus. So for each course of action, identify the maximum regret value, and we will select the smallest anticipated opportunity loss value. As I said earlier, we will be concerned about the column, not the row, unlike that of the other criterion. So first, we will determine the column maximum, which in this case, in state of nature number 1, 7,000, state of nature number 2, 4,500, and 3, 3,000. So after determining the column maximum, we will subtract this, wherein in strategy 1, state of nature number 1, 0 into 1,500 and 1,500 with the highest of 1,500. In strategy 2, however, 7,000 minus 5,000, 2,000, 0, 3,000, and with the highest of 3,000. In strategy 3, 7,000 minus 3,000, 4,000, 4,500, 3,000, 1,500, and 0 with the highest of 4,000. As we said earlier, we will choose the smallest anticipated opportunity loss value, and in this case, the smallest is the strategy 1, which we will choose. So we are now done with the decision theory, which includes its fundamentals, the decision environment, the decision making under uncertainty and under risk, which we define the uncertainty, the certainty, and the risk, and we also identify the criteria of decision making under uncertainty. That's all for decision theory, and thank you for listening, everyone, and keep safe. May God bless us all.